I'm Anil Kumar. Welcome to my series on exponential functions. We are going to discuss how do we sketch a graph of an exponential function in this particular video. So we'll take a transform function of the form y equals to a. We have taken base as 3 in this example to the power of kx minus p plus q. We'll describe the transformations and then sketch the transform function. So the example taken here is y equals to minus 1 over 3, 3 to the power of 2x plus 2 plus 5. We need to first describe the transformation from the parent function y equals to 3 to the power of x, sketch to show each transformation in order, and then check the above graph with transformed key points. So that is the exercise which we need to do in this particular video. I'd like you to pause the video, answer the question, and then look into my suggestions. We'll begin with understanding the basic transformation from our general equation. So we have taken the general equation y equals to a 3 to the power of k x minus p plus q. If that is the equation given to you, then what are the transformations? And how do we write them in order? That is another very important thing. So writing in order is basically to first apply the stretches, compressions, and reflections, then translation. So that is the order. Now, as far as stretches, compression, and reflection is concerned, it could be in any order. You could first do reflections, then compressions and stretches. You could do horizontal stretches, compressions first. The order can be interchanged within this group. Translation could be horizontal or vertical, correct? So that will be followed by it. So it's like multiplication followed by addition and subtraction. So that is the order which we should be maintaining. Now, for any general expression like this, it really means that there is a vertical stretch by a factor of a. We are assuming all the values to be positive. Horizontal compression by a factor of 1 over k. Horizontal translation of p units right and horizontal translation q units up. And the equation for the image point is any point xy on the graph of e to the power of x will now be 1 over k times x plus p, that's the x coordinate, and the y coordinate gets multiplied by a, and then you add q. So that takes care of vertical transformations. The graph of e to the power of x is given to you, and we'll also consider the key points. So let me rewrite the key points on the parent function y equals to 3 to the power of x. Well, the key points are that if x value is minus 1, in that case, the y value will be 1 over 3. If x value is 0, anything to the power of 0 is 1. If x value is 1, we just get the base, and if x is 2, 3 squared is 9. So these are the key points. And another very important key point is the horizontal asymptote. When x is approaching minus infinity, y approaches 0 from the positive side, and when x approaches positive infinity, y approaches positive infinity. So that is the end behavior, correct? So we're talking about two more points, which is horizontal asymptote and end behavior, correct? So these are the points to be considered whenever you're sketching exponential function. Now let's see, how do we sketch exponential function for the given function? Let's first talk about the transformations. We are given y equals to minus 1 over 3, 3 to the power of 2x plus 2 plus 5. We need to describe the transformation from the parent function y equals to 3 to the power of x. First step here is that you need to factor the horizontal stretch and compression factor. Remember, the equation is 3 to the power of k, and within bracket they got x plus or minus p. So in this case, the first step should be factor this part. Only when you factor this, you get the horizontal translations correct. Otherwise, you'll make a mistake. So what we have done here is written the equation as minus 1 over 3, 3 to the power of 2 is factored out, x plus 1 plus 5. Now we get the correct translation, the horizontal translation, right? So, beginning from left to right, the order can be maintained. So you could describe transformations from left to right. So if I do that, then the order will always be correct. So arrange the equation in the standard form and then describe. So beginning from here, this minus here indicates what? The minus here indicates the reflection on the x-axis. And now we'll look into the factor 1 over 3. That factor 1 over 3 is the vertical compression by a factor of 1 over 3. And now let's look into the horizontal part inside the function. The factor k equals to 2 means that there is a horizontal compression by a factor of half 1 over 2. And then the translations, it is horizontal 1 unit left and 5 units up. And that is what we have mentioned here. So that is the description of the transformation for the given function. Correct? We should also write the image points, right? So these transformation corresponds to the link between the points on the original parent function to the transform function as follows. xy, if that is the coordinate point on 3 to the power of x, in that case in the function, the x values get multiplied by half and then you subtract 1, representing translation towards the left side. The y values get multiplied by minus 1 over 3 and then you add 5. So that becomes the set of corresponding image points. Correct? Another important thing to again emphasize is the order of transformation. So we'll now sketch these graphs in the correct order. The order followed will be, we'll look into reflections, then stretches and compressions. These will be followed by the translations. Now let us see how do we sketch the transfer function following the order of transformation. So we'll begin with the function which is y equals to minus 1 over 3, 3 to the power of 2 x plus 1 plus 5. We just saw that the transformations are 1, we have reflection on the x-axis. That takes care of minus, right? And the second one we'll look into is vertical stretch. Let me write vertical stretch by a factor of 1 over 3. So we can say, strictly speaking, a vertical compression since we are compressing it. So we'll write vertical compression by a factor of 1 over 3. Then horizontal, this 2 reflects the compression. So we have horizontal compression by a factor of 1 over 2, right? 1 over k. And then we look into translation, and that will be 1 unit left, 1 left, and 5 up. So these are the transformations which we are going to do in steps. We'll begin with the parent function, which is y equals to 3 to the power of x. And on the parent function, as you can see here, we have our critical points, right? So these are the critical points. Horizontal asymptote, which is y equals to 0, and here the end behavior. As x approaches infinity, y also approaches infinity. So those are the key points which will be considered in the transformation. So the very first one here is minus of 3 to the power of x. Now this minus actually reflects the graph on the x-axis, and what results is the graph highlighted. All the key points will now be seen in quadrant 3 or 4 below the x-axis, since the graph of y to the power of 3 to the power of x is being reflected on the x-axis. Clear? So that is how we are going to do the first transformation, and which is to reflect on the x-axis. Now, let us see how do we perform vertical compression. So now we'll see minus 1 over 3 times 3 to the power of x. Minus 1 over 3 means vertically compressed. To compress it vertically, each point is now, the y value is divided by 1/3. So you see here that the value, which was, let us say 3, now becomes 1, and the value which was minus 1 now becomes minus 1 over 3. So that is how you do vertical compression. Once the vertical compression has been done, we'll do the next transformation, which is horizontal compression by a factor of half. Horizontal compression by a factor of half means that the points will move half the distance from the origin, right? So we'll now sketch the graph of 1 over 3, 3 to the power of half of x, correct? So this, at this stage, you can see that the points will move horizontally, where the x becomes x by 2. And we get the points as shown on the orange graph. Correct? So this is the graph which we get now after horizontal compression. Once the horizontal compression has been performed, then we'll look into the, the translations. So first step is we did the translation 1 unit left. So each point has now been moved 1 unit left, as you can see that. So that is the left movement of each point. So in this transformation, we have adopted these steps. We have not really calculated the image points, right? So now we get the graph of minus 1 over 3, 3 to the power of half, x plus 1. That is the translation horizontally by 1 unit. And last is to translate the graph 5 units up. So each point from here now is moving 5 units up, as you can see. So once you do that, in that case, you get your final graph. And you will realize that now the horizontal asymptote is at y equals to 5 instead of y equals to 0. Correct? And you get your final points as shown here. So that is how you perform the transformation in stages to get your final graph. Correct? Now let us see, how do we check that this is correct? Well, that could also be your first step. That is, you could calculate the image points. Now we know that the transformation is reflection on the x-axis, vertical compression by a factor of 1 over 3, horizontal compression by a factor of half, translation 1 unit left and 5 units up. That gives you the transformation of key points as shown here. The x values will become half of x minus 1, and the y values will be minus 1 over 3y plus 5. So we'll begin with our parent function points, which were minus 1, 1 over 3, 0, 1, 1, 3, and 2, 9. To get the transformed points, we'll multiply the x values by half and take away 1. So in doing so, we get the x value for the first quadrant as minus 3 over 2. To get the y points, we'll multiply them by minus 1 over 3 and add 5. And so the point which was minus 1, 1 over 3 will now map to the image point 3 over 2 with negative sign over 44 over 9, which is one of our points. Do you see that? So that is how you could check if your graph is correct. For the point which was 0, 1, the y-intercept, the x value will be minus 1 and the y value will be 14 over 3 as shown here with the calculation. So in this transformation, substitute 0 and 1 for x and y and calculate your result. Perform the same for the other 2 points and you can now match them as shown on the graph. Perfect. Also look into the horizontal asymptote, which is the key parameter. Earlier, the horizontal asymptote was defined as when x approaches negative infinity, y approaches 0 from positive point, right? So this is when x approaches negative infinity, y approaches 0. That gets transformed to when x approaches, now in this case, negative infinity, then y approaches 5, correct? Since it has been translated 5 units up. That is because of this 5 here, correct? So that is the horizontal asymptote. So we have a horizontal asymptote y equals to 5 in our graph. Also you will notice that when x approaches positive infinity, y approaches negative infinity. This is because of the reflection on the x-axis. This is because of the reflection on the x-axis. Correct? So those are key points which we need to check when we sketch our graph. And so we do get horizontal asymptote, which is y equals to 5. And the graph and behavior is that it is approaching negative infinity as shown here. And so we do get domain and range also from here. The domain is that x belongs to real numbers. However, the range is y belongs to real numbers where y value is less than 5. That could be an important part of this question at times. So if you're asked for domain and range, you may conclude domain and range also. You should write domain and range also in as a part of your solution. I hope that helps you to understand the basic concept of sketching a transformed exponential function in steps. So basically, there are two steps, two ways of doing it. One, you could follow the transformations and sketch the graphs one by one. The other one is to calculate the key points, plot them, and then sketch your graph. I hope that helps. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.